Now we are going to solve effective resistance across A and B. A and B means across one edge of a cube. Here we have taken 12 resistors. Each resistors are equal. Each resistors are these resistors taken along the sides of a cube. Now to find effective resistance across A and B, we have to assume that we are connecting A and B to the battery, like that we have to assume. Now we are connecting battery to the A and B, we have to assume. Now see here current drawn from the battery I is there. This current is comes. This current as it comes enters at junction A. This current divides into three paths. In these three paths, let us see here, in this path and in this path are identical paths, so that in this path and in this path current should be same. So here I dash means here I dash current will be there. That means in this resistance and in this resistance, potential should be same. Potential difference should be same. Because in this resistance current and in this resistance currents are equal, so that potential difference across these resistance should be same. That means this point, common point is there, and in these points, let us assume this is as a point 1 and this is as a point 2. At point 1 and point 2, potential should be same. Because here current and in this resistance current same, so that here potential difference same. So when we connect this point 1 and point 2 same, since point 1 and point 2 are same potential, when we connect these 2 points by the wire, current will not be passes through the wire. Then this resistance and this resistance, that means across A and 1, A and 2, these two resistance are parallel. And let us take this point as a C. Across C and 1, C and 2, these resistance are parallel. Similar way, when we come to this point, here in this point, let us take this point as a point 3. Here current at point B, current what happens means in this resistance, current will be entering point B. Let us take as I dash, and in this resistance also I dash. In this resistance and in this resistance, same identical path, so that current will be same is there. So point B, current entering through this resistance are equal. So that in this resistance and in this resistance, potential difference same. So that potential at point 3 and potential at point 4 must be equal. Since potential at 3 and potential at 4 are equal, so by connecting this 3 and 4 by the wire, here current will not be passes through 3 and 4. That means potential difference across resistance B and 3, B and 4 are equal, so that resistance between B and 3 and B and 4 are parallel. And if we consider this the point D, here between D and 3, that resistance, and between D and 4, these resistance are parallel. Since these two resistance are connected, first terminal common point, second terminal also another common point is there. Now by rearranging this diagram, we can get effective resistance. Let us rearrange this diagram now. See here, we take first this point A and B is there. This A and B we are taking like this. A and B is there. Now these two resistance A across A1, A2, these two resistance are parallel. So that these two resistance we take as a parallel means R by 2 will be there. This point we can take as a 1 and 2. This point we can take as a 1 and 2, 1 comma 2. And these two resistance between C and 1, C and 2, these two resistance are parallel. In parallel, if we connect, that is R by 2, we will get this point taken as a C. And here we take in point B, we take these two resistance are parallel, so that is R by 2. This R by 2. This point is, this is 3 and 4. So 3 comma 4 we take. And these two resistance across D and 3, D and 4, these two resistance are parallel. That is we take as a parallel, so R by 2. Between 1 and 2 and 3 and 4, there are two resistance there. These two and between 2 and 4, one resistance there. Between 1 and 3, one resistance there. So the 2 and 4, one resistance we are taking. And between 3 and 4 are between 2 and 4, one resistance we are taking. And between 1 and 3, one resistance we are taking. Between 1 and 3, one resistance we are taking. These one resistance are, these one resistance are. Now between point C and D, this is the point D. Between C and D, one more resistance is there. Like that is there. Now we take this effective resistance, these resistance, these two are in parallel, so that R by 2. Now these resistance are in series, so this is as a 2R. Then by simplifying this diagram, we are going to rearrange again this diagram as a, here this is the point A, this is point B. We have to find effective resistance across A and B only. Here R by 2 is there, and here R by 2 is there. Now this effective resistance we are taking as the R by 2. these are, and these complete resistance as a 2R, because this R by 2, this R by 2 are in series 2R. Now this R by 2 and these two are in parallel. R by 2 and 2 are in parallel. If you take, how much you are getting means 2R by 2R into R by 2 divided by 2R plus R by 2. By simplifying this one, we will get this one as a 2R by 5. Again by simplifying this diagram, rearranging and drawing this diagram, we will get as a this A and B, this point A, this point B. Now here R by 2 is there. This completely together 2R by 5 and this R by 2. Now see here these three resistors, that means these three resistors are in series. This R by 2, this R by 2, or this 2R by 5. So parallel series. So 2R by 5 plus R. This R by 2, 2R by 5, this R by 2 are in series. So that answer is this, for this 7R by 5 comes. Now again simplifying this diagram, we can redraw as this is the A and B, this is the R. Now these complete resistance together as 7R by 5. Now these two resistance are in parallel. So in parallel combination, effective resistance we are getting as 7R by 5 into R divided by 7R by 5 plus R. So altogether this answer is, by simplifying, we will get 7R by 12. This 7R by 5, this 7R by 5. So by simplifying, we will get as a 7R by 12. So effective resistance when we find across the edge of the cube, we are getting as effective resistance. The effective resistance across the edge of the cube, we are getting as a 7R by 12.